In this video, I want to have a look at angles of elevation and depression when we're looking at trig. So the angle of elevation is measured from the horizontal looking up, and the angle of depression is measured from the horizontal looking down. So what that looks like is if you imagine a big skyscraper, this is a building here, and there's somebody on the ground. So they're standing a little bit away from the building. If they're looking up towards the top of the building, so let's draw a line down there, that angle that they're looking up, that's our angle of elevation. Now, if you imagine there's somebody standing on the top of the building and they're looking down, then the angle that they have to look down is the angle of depression. But it's still measured from the horizontal, so we need to draw a horizontal line in there. And that angle that they have to look down, that there would be our angle of depression. So let's have a look at what angles of elevation and depression look like in problems. So our first problem says, Luke walked 400 metres away from the base of a tall building on level ground. He measured the angle of elevation to the top of the building to be 62 degrees, and we want to find the height of the building correct to the nearest metre. So we've been given a diagram. So this is our building here. It says Luke walks 400 metres away, so that means Luke's the one standing over here. And it says the angle of elevation to the top of the building is 62 degrees. So that's our angle in there, has been measured to be 62. It asks us to find the height of the building. So that's going to be this length along here. So we're going to give that a letter. We can call it whatever we want. We could call it X, Y, D. Because it's the height, maybe we should call it H. But it doesn't matter what you pick. So that side of that triangle, we've given the letter H. So all it is now is a SOHCAHTOA problem, so figuring out which ratio we use to find the unknown side. It just looks a little bit more complicated because there's lots of words and it's in a diagram this time. But from this 62 degrees, that H is our opposite side, and our 400 metres is our adjacent side. So we know, if we're at SOHCAHTOA somewhere, so we've got opposite and adjacent, so that means we're going to be using tan. So we're going to write tan theta equals opposite over adjacent, and then fill in what we know. So we've got tan 62 degrees is equal to H over 400. Now to get that H on its own, we're going to multiply both sides by that 400. We'll have 400 times tan 62 degrees is equal to H. And then we can put that in our calculators. We'll end up, it says answer correct to the nearest metre, so that's going to be the nearest whole number, would be 752 metres. So it's saying that that building is 752 metres tall. Let's have a look at a problem that involves an angle of depression. So we've got the angle of depression from the top of a TV tower to a satellite dish near its base is 59 degrees. So that's our angle of elevation there. This here is our TV tower, and this would be our satellite dish over here in this corner. It says the dish is 70 metres from the centre of the tower's base. So this is the 70 metres along here. So that's our satellite and our tower. And it's asked us to find the height of the tower. So it's already told us, it's already called that X. Now the problem with this is that right now we don't have an angle inside that triangle, and we need to have one to be able to use trig. So there's two different ways you can do it. You can look at this and say, okay, well, we know that that's a right angle in there. A right angle is 90 degrees. So if we want to find the size of this angle here, we can go 90 minus 59. And that would give us 31 degrees in there. So now we've got one in there. We've got our opposite side is our 70 and our adjacent is our X. So we've got a tan problem again. So we've got tan theta equals opposite over adjacent. So our theta is that 51. It has to be the angle that's inside. So tan 31 degrees is equal to 70 over X. So this time that X is in the denominator. So we're going to have to multiply both sides by X. So X times tan 31 degrees equals 70. And then to get the x on its own, we're going to divide by tan 31. So x equals 70 over tan 31 degrees. And put that in our calculator. And asks us to answer correct to one decimal place. So we'd have 116 point. The next number is 4, but because the one after that is a 9, that means we're going to round up. So it'll be 116.5 meters. Right, so that's 2 examples of problems involving angles of elevation and depression.